Hello, and this is the Chapter 8 review. Please feel free, if you get an answer correct, to go ahead and fast forward through the explanation of that answer, or please feel free to go ahead and listen to that explanation if you would want further clarification. Let's get started. Let's look at 1b. I need to completely factor negative 52a squared b. So what I'm going to do here is I'm going to factor a negative 1 out right away so I don't have to worry about the negative 1 later. I'm going to break down 52, and I know 52 breaks down into 2 times 26, and 26 breaks down into 2 and 13. So now when I write my final answer, it will be negative 1 times 2 times 2 times 13 times a times b. Still under the subject of 8.1 monomials and factoring, let's take a look at 2c. So here I'm going to completely factor 30, and I'll write my work over here, 30q cubed r squared t, and I will completely factor 50q squared rt. So I know 30 breaks down into 15 and 2, and 15 breaks down into 5 and 3. So this is 2 times 3 times 5 times q, r, t. And I know that 50 breaks down into 25 and 2, and 25 breaks down into 5 and 5. So this is 2, 5, 5, q, r, t. Now I'm going to circle, or in this case highlight, what the two have in common. So let's see here, they share a 2, 5, 2 q's, an r, and a t. So my final, or the GCF, of these two monomials is 10, because 2 times 5 is 10, q squared rt. Under 8.2, using the distributive property, let's look at 4b. So I see 3 terms here, so that tells me, using the distributive property subject, that I need to use the distributive property. So I need to take out the GCF of 7u squared t squared, 21ut, and ut. And so what they share is just a ut. Now I draw in my parentheses and undistribute. So if I'm at ut, how do I get to 7u squared t squared? 7ut. If I'm at ut, how do I get to 21ut squared? Minus 21t. And if I'm at ut, how do I get to negative ut? Minus 1. And again, I could check my answers by going through and distributing what I got for my answer, distributing that ut to all 3 terms inside my parentheses, and I should get back to what I started with. Now let's look at 5, factor each polynomial, and specifically at part B. Now on this problem I see 4 terms, so that should remind myself to use factor by grouping, and the first step with factor by grouping is regrouping if necessary. I look at these terms and I'm going to leave them as they are, and I'm going to group the first 2 terms together, the last 2 terms together. Now I look at my first 2 terms and take out the GCF of 3np and 15p, which is 3p, undistribute now, and I get n plus 5. Now I look at the next 2 terms of negative 4n minus 20, and I take out the GCF there of negative 4, and then get n plus 5. And that's great because I should see the same term, or the same factor, listed twice. And how I write my final answer is I put my terms that are outside of the parentheses together and get 3p minus 4, and then write my 2 factors that I see only one time. And if I FOIL or use the box method and multiply these 2 binomials back together, I will get, in fact, what my original problem was. Now let's look at question 6 that says solve, and I'm going to specifically look at 6c. So x squared equals negative 10x. I need to solve. So first I'm going to add 10x so I can get my equation equal to 0. So I get x squared plus 10x equals 0. And now I'm going to factor out the GCF of x squared and 10x and take out an x and get x plus 10 equals 0. And now that I've factored, I now can set my two factors equal to 0. So I'll set x equal to 0 and x plus 10 equal to 0. And my answer here is just 0. And here is negative 10. So my two answers are 0 and negative 10. Now to check my work, I could plug those values back into my original equation here, and that will satisfy the equation. Now we are on 8.3, quadratic equations in the form of x squared plus bx plus c equals 0. So let's look at 8a. The directions here say to factor, and I'm going to factor by using the diamond method, and I know to use the diamond method because there is a 1 in front of x squared. So I will put c on the top, which is 24, b on the bottom, which is 11, and now I need to ask myself what are factors of 24 that when added together give me 11. Those are 8 and 3, so this factored form is x plus 8 times x plus 3. Number 9 says solve each equation, and let's look at 9a. The first thing we need to do with this equation is get this equal to 0. So I'm going to subtract 70 to both sides and get z squared minus 3z minus 70 equals 0. Now I'm going to use the diamond method, and again because I have a 1 in front of z squared, so factors of negative 70 that when added together give me negative 3. And these factors are negative 10 and positive 7. So I get z minus 10 times z plus 7 equals 0. And when I really set these factors equal to 0, the signs change. So my two solutions are 10 and negative 7. We are going to move on to 8.4, quadratic equations in the form of ax squared plus bx plus c equals 0. We are going to take a look at 11b. So with the 11b here, I need to factor, but I'm going to use a snowflake method, and the reason I'm going to use a snowflake method is because there's a 6 in front of x squared. But before I do that, I'm going to notice that I can factor out a GCF. A GCF of 2 can be factored out. So if I take out a 2, I then get 3x squared plus 11x minus 4, which still means I do need to use a snowflake method because there is a 3 now in front of x squared. So in order to fill out my snowflake, I need to put a times c at the top, so 3 times negative 4 is negative 12, b on the bottom, a in the other two top spots. And now I need to ask myself, what are the factors of negative 12 that when added together give me 11? And those are 12 and negative 1. And then before I write out my factors, I need to simplify my fractions on the sides to 1 over 4. So that 2 comes in my answer. X plus 4 I got from this first fraction. And then this second fraction here becomes 3x minus 1. And that is my answer. Number 13 reads, a person throws a ball upward from a 506-foot tall building. The ball's height, h in feet, after t seconds is given by the equation h equals negative 16t squared plus 48t plus 506. The ball lands on the balcony that is 218 feet above the ground. How many seconds was it in the air? So let's take a look. I need to plug in 218 in for h because that's the height that the ball will land on the balcony at. So 218 equals negative 16t squared plus 48t plus 506. Now I'm going to solve this equation by first subtracting 218 to both sides and get 0 equals negative 16t squared plus 48t, and 506 minus 218 is plus 288. Now I'm going to factor out a GCF of negative 16 in all those terms. So 0 equals negative 16 factors out. I get t squared minus 3t minus 18. Now I only need to use the diamond method because I have a 1 in front of t squared. So factors of negative 18 that when added together give me negative 3 are negative 6 and positive 3. So when I write out my answer here, I have t minus 6 times t plus 3 equals 0. And my two answers are positive 6 and negative 3. But if we're looking at time and how many seconds something is in the air, we don't want to use the negative answer. So my answer here is just 6 seconds. Now let's go on to 8.5 difference of squares, and let's look at question D here. So I'm going to look at negative 4y cubed plus 9y, and the first thing I'm going to look at is factoring out a GCF. And I'm going to take out a GCF of negative y and then undistribute and get 4y squared minus 9. Now I continue to look at 4y squared minus 9 and realize it is a difference of squares, and break that down into two binomials that are almost the same. Take the square root of my first term and get 2y. Take the square root of my last term and get 3. And one has a plus sign, the other has a subtraction sign, and that is my final answer. Okay, 8.6 perfect square trinomials. Question 15. Determine whether each trinomial is a perfect square trinomial. Write yes or no, and if so, factor it. So let's look at part A. In order to have a perfect square trinomial, I need to be able to take the square root of the first term times the square root of the last term times 2 or negative 2 to equal the middle term, and if it does, you have a perfect square trinomial. If it doesn't, you don't. So let's look at A. The square root of my first term is 3y. Square root of my last term is 4. My middle term is positive, so times a positive 2. If all those together multiply to be negative 24y, we have a winner with a perfect square trinomial. So 3y times 4 is 12y, times 2 is 24y, so it works. Good news, now let's factor this. And this factors into the same binomial. And so the square root of my first term goes in the first spot, square root of my last term goes in the last spot, and then the sign that's with your middle term is the sign that is in your binomial. And that is our factored form answer for question 15A. More factoring. Let's look at 16A. We need to factor, so the first thing I'll do here is take out a 2, undistribute, and get x squared minus 16. Now I'm going to continue to factor x squared minus 16 because that's a difference of squares. So I take out a 2 and get x, 4, and 4. One is a plus, one is a minus. 17 says factor and solve. So let's take a look at 17b. Now before I can attempt to solve this, I need to get this equation equal to 0. So I'm going to subtract 9 from both sides and get 64y squared minus 48y plus 9 equals 0. Now, I know I can easily take the square root of 64y squared and 9, so let's check and see if this is a perfect square trinomial. Square root of my first term is 8y, square root of my last term is 3, and then since my middle term is negative, that times negative 2, if that equals negative 48y, we have a perfect square trinomial. So 8y times 3 is 24y, times negative 2 is negative 48y, so this is, so let's factor this into two binomials that are this exact same. And I get 8y here, 8y there, 3, minus, minus. So really, I only have to solve one of these because I'll get the same answer twice. So if I set 8y minus 3 equal to 0, I add 3, get 8y equals 3, divide by 8, and I get y equals 3/8. So that is my solution to 17b. Now we are going to take a look at the Chapter 8 multiple choice review and just a few questions on this. So let's look at number 5. Number 5 says solve the equation. So first I'm going to factor out a GCF of 4x, undistribute, and get x minus 4 equals 0. So now that I've factored this, I need to now set my two factors equal to 0. So 4x equals 0 and x minus 4 equals 0. So my first answer is 0. My second is positive 4. So let's look at where we see 0 and 4, which would be option C. Let's also take a look at problem number 15. Which trinomial is not a perfect square trinomial? So in the Chapter 8 review packet, we did talk about what classifies a perfect square trinomial. we need to be able to take the square root of our first term times the square root of our last term times either a 2 or negative 2 to get our middle term. So let's take a look here at part A. A says 4x squared plus 4x plus 1. So if I take the square root of 4x squared, I get 2x. Square root of 1 is just 1 times 2. If that gives me 4x, I have a perfect square trinomial. 2x times 1 is 2x times 2 is 4x. So A is a perfect square trinomial, so that would not be our right answer because we're looking for one that is not. Let's look at B. Square root of my first term is 7x times square root of my last term is 4y times a negative 2 has to equal negative 56xy. 7x times 4y is 28xy. 28xy times negative 2 is 56xy, so that one will also work. Let's look at C here. So square root of my first term is x. Square root of my last term, can I take the square root of a negative number? You cannot, so C will not be a perfect square trinomial. So that is our answer. I mean, we could check part D just to be safe. I'm not going to right now, but on your final, that would be a great idea. Okay, so we went over the Chapter 8 review packet and just a few questions of the Chapter 8 multiple choice review. If you have any questions, please let me know. Otherwise, feel free to work on whatever problems you would like and check the answer key on Google Classroom. Good luck!